Hey guys, welcome to your video one for your extended spring break. We're going to be going over the real number system, which is something you've already learned, but it was at the beginning of the year, so we're just going to brush over a little bit to make sure you fully understand it. So let's just think about the real number system. The real number system is made up of all rational and irrational numbers. So we're going to go through each one of these real quick, but I also did post on the document that I shared. It has the Colin Dodd video that we watched in class, which is, it's really cool and you really like it, so go ahead and watch it a second time. You will love it the second time. But it talks about natural numbers, and when it talks about natural numbers, it talks about how natural numbers are numbers that you can count on your hands. It's my beautiful hand. Your hands and your feet, okay? So numbers you can count on your hands and feet, like 1, 2, 3, and it just keeps going. It's something you can naturally say. I can naturally say 102, even though I don't have 102 fingers and hands, and that's okay. Okay, so you think about it, when the example I use in class is when you talk about a baby, you don't say, oh, that baby's a half a year old. No, you say that baby is 6 months old. So it's just something that you naturally say, okay? Then you have whole numbers. Whole numbers are all the natural numbers plus 0. So we're going to have 0, 1, 2, 3, and then we're going to keep going. 102 is in here too. Okay, so it's all your natural numbers plus 0. You're going to have that 0. Then we have integers. Integers are all your whole numbers plus their opposites. Okay, the opposite of 102 is negative 102. Opposite of 3 is negative 3. So we're going to put the dots here on this side as well, because that's the way on our number line the negatives go. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Almost forgot my numbers for a second, but it's all your whole numbers plus negatives. Okay, and then rational numbers are all your integers plus anything that you can put into fraction form. So in the example or on the definition, it's going to say A over B, which just means something, sorry, I'm not used to this board, something you can put into a fraction form. That looks horrible. Okay. Something you can put into a fraction form. So a fraction, let's say 1/3, that's a fraction. Well, what about 4/3? That's a fraction. It's an improper fraction, but it's still okay, it's a fraction. You can also put like 2 and 1/2. Mixed numbers work too. So all of those go. Plus you can have your negative 3, you can have the 0, and you can have any natural number. We'll just put 1. Okay, there's a couple other ones that we want to put in here. Okay, so a fraction. We also can put decimals. Okay, if it's a repeating decimal, if it repeats, it's rational. Okay, like let's go with 3/10 repeating. 3/10 repeating can be put in a fraction because it can be put in 1/3. Okay, excuse me. The first week of school we went over repeating decimals. We did 1/9, 2/9, 3/9. We also did our 11ths. Okay, so we learned that if it repeats, it can go into a fraction form. Okay, if it terminates, if it ends, remember terminating decimals are ending decimals. So if you have like 2 and 4/10, we'll just say 2 and 4/10. 2 and 4/10 end, so we can easily put that on a number line, therefore it's rational. Okay, and two other ones to think about, square roots. If it is a perfect square, like the square root of 25, that's going to give you 5. Because remember that square root says what times itself? Well, 5 times itself is going to give you 25. So we can put the square root of 25 in here. Okay, and the other thing is the absolute value. What is the absolute value of 10? Well, it's 10. Because the absolute value bar, remember, that means the distance a number is away from 0. So the absolute value of negative 10 is 10. It's just how far it is away from 0. All right, so those are our rational numbers, okay? But let me pop this question for you real quick. If these are all rational numbers, what if I put, and I said, oh, well, what is 2? Well, we know that 2 is a whole number, right? What are the other things that 2 is? 2 is a whole number, but because it's a whole number, it's also an integer, it's also rational, and it's also real. So it's not just a whole number, it's an integer, rational, and real because it's in those boxes as well. Okay, what about negative? Oh, let's do 2 and 1/2. What is 2 and 1/2? What can we classify it as? Well, we know it's rational and we know it's real, and that's about all it is. Okay, but if it's a natural number, it's a natural, it's whole, it's an integer, it's rational, it's real, it's all of those except irrational. Okay, so I think we should be good on rational numbers. Let's go ahead and go to irrational numbers. Irrational numbers, I like to say, are not rational. Okay, so they're not rational, which means they are not going to fit on a number line. Okay, and we would say non-perfect squares. So if the square root of square root of 25 is 5, okay, we want a non-perfect square. So let's say we know that the square root of 4 or 16 is 4, and that the square root of 25 is 5. So those are perfect squares, okay? But anything in between those, so let's just pick a random number. Let's go square root of 20, okay? We know it's 4 point something, but we don't know an exact number. And if you put that in your calculator, it's going to come up with all these numbers, and it's not going to repeat, and it's not going to terminate. Therefore, it is not rational. So non-perfect squares are not rational. Okay? So decimals that do not repeat, they do not end. And you cannot put them in fraction form. So let's think about, let's go ahead and put the square root of 20 over here, because we know that's not a perfect square. Okay? We can also do pi. Remember we had that awesome pi day? Way to end school for, your 3 weeks of spring break. But pi is irrational because it never ends and it never repeats. And if you remember on my chalkboard, you can see that it goes 3.1415265545, and there's tons of numbers that goes all the way around. So it is going to be irrational. So that's just a brief thing about rational and irrational. But let's think about it in a different way, because sometimes we get confused over what's rational and what's irrational and why. Okay, so just like we said, if it's a 2 is a whole number, it's also going to be an integer, rational, and real. But let's kind of do a little real world example. Okay, so let's draw another one of these. Okay, this is going to be my classroom. Okay, and I'm quite the artist. And inside, my classroom is inside White Oak Middle School. You should agree with me on that. So, and then White Oak Middle School is in White Oak, right? And because we're in White Oak, we're also in the great state of Texas. Okay? So, we'll go with first period. So Tristan, let's get Tristan green. So Tristan is in my classroom. Okay, and because Tristan is in my classroom, all I have to do is say, hey, Tristan's my classroom, and you're going to know that he's at the middle school in White Oak in Texas, because that's where my classroom is. Okay, but if I tell you I'm videoing this super cool video that you're going to love, and I am just in a White Oak, I'm not at the middle school, and I'm not in my classroom, but I'm in White Oak, and I'm also in Texas. So the same thing associates here. Because the number is a whole number, it's automatically going to be an integer, rational, and real. Just like Tristan's in my classroom, he's automatically going to be at the middle school in White Oak and in Texas. Okay? And the whole real number system is made up of rational and irrational. In my classroom, it's kind of made up of boys and girls. It's everyone together, just like the real number system. Okay? So if you do have questions, please email me anytime. Send me a DM on Instagram if you have that. If not, it's no big deal. But go ahead and do that. Do the Quizlets and then do the quizzes. You can do them up to 2 times. Do your best. Thanks.